Welcome back everybody to episode 31. We're going to start talking about object-oriented programming. So in the beginning of this series I said that there's a bunch of different styles of programming, and this is just one of them. It's called object-oriented programming, and it's denoted as the acronym OOP. So you'll see that more often than you'll see object-oriented programming. Anyway, in object-oriented programming, the three words you should know are class, struct, and object. So let's think of class and struct as the same thing. And all they are is basically a template or a category of things, and then the actual things are the objects. So let's take an example here. We have the category, quote unquote, of animals, and then we just create this as a class. So the class is a template of what an animal is. So now we can create different objects that are animals, basically. So a pig is a type of animal, so that would be appropriate to create from the class animal. And a cat is a type of animal, so that would be a different object of the animal class. So anyway, every object has attributes and methods. Now we go ahead and state these attributes and methods in the class. So in the class, well, first off, attributes are the things that describe the object, and then methods are the things that the object can do. So for instance, in the class animal, we could say that we have an attribute called color. So this could be the color of the animal, and every animal has a color, so this would be inside the class animal. Now when we go ahead and create a pig object from the animal class, we have to specify its color. So we'll say the color of the pig object is pink, and then the color of the cat object is like tan. Anyway, we have methods as well, and I said those are the things that the object can do. So in the animal class, we can have a method called talk. So every animal makes some sort of sound for the most part. So a pig would have the talk function saying oink, and the cat function would have the cat's talk function would say meow, something like that. Anyway, each attribute and method of each object is going to be public or private, and we'll talk about that in this example. Okay, I'm going to be explaining object-oriented programming using C++ because Java is a little weird and it just uses classes for everything. Let's get started. I'm going to need the IOStream library to print to the screen at some point. Anyway, we're going to be using the namespace std, and then I'm going to create the main function here. So in C++, we have to return 0 to indicate that the program ended successfully. And then anyway, now we can go ahead and create our classes. So we're going to do this outside of the function, and we'll say we have a class. So this is like a template, and we're going to create a human class. So we need to basically describe what's common with humans. So every human has an eye color, so we'll create that as an attribute. We'll have an attribute section and a method section. So there we go. And the eye color is an attribute because it describes each human. So we'll have a string eye color here, and we'll just leave it at that. Another attribute could be something like the height of the human. So float height like this. And then we could have something like the gender, so a char, M or F for male or female. So we'll just call this gender. And then we have different methods. So we'll just do one. So we'll say our one human method is to talk. So we'll say void talk, and then we'll pass in the string that we want the human to say. So we'll just say a line. And now we need to end this class. So we just end the curly braces and put a semicolon. It's different from a function because you have to have the semicolon. Now, let's go ahead and create an object of this class. So we'll call the class name human, and then give this object a name. So I'm going to create a human called Bob. Okay, now Bob, we're going to set his eye color. So we're going to use this dot operator to access everything inside the human class. And we're going to go ahead and say eye color is equal to brown. Okay, just like that. And now we're going to go ahead and print out. So we'll say cout Bob's eye color is equal to, and then we'll end that like so, and then we'll add on, or we'll just print out Bob dot eye color, because this will get his eye color. And now if we go ahead and run this, we're going to probably run into some errors. So I'm going to change directories to where that file is located. So there you go, there's my main. So I'm going to compile this using the MinGW compiler. So main.cpp. We've seen this before, then I'm going to, there's our errors. So let's see here, it says is private. So here's where our private and public comes into play. So we have what's known as a private section of a class and a public section. So anything that is denoted as public and anything under the public here is going to be public. We can access public stuff anywhere outside of the class. So in the main, we can access the public stuff. So if I go ahead and save this and try to compile it now, it should work. Let's see. Brown was not declared in the scope, and that's because it's a string and I just set it as a variable. So we'll say brown like that, and now it should compile. And there you go. Anyway, it compiled because now everything's public and we can access it outside of the class, and this is the scope of the class. Now if I return this to private, now it's going to give us the errors if I compile this. There we go, errors. And the difference between private and public is private, it's only accessible within the confines of the class. You can't access it outside of the class, like in the main. Now the difference between class and struct, I said they're basically the same, but there's this one discrepancy. With a class, if I didn't say exactly what whether these things were public or private, it would just be assumed as private with a class. That's why we got errors. But if I change this to a struct, then everything is now assumed to be public, and that's the one and only difference with the class and struct. So if I use a struct and didn't specify this was public, it would still work because we're using a struct, and you can see there it compiles. So let's revert this back to class, because more often than not I use classes. I don't know about other programmers, but that's just my preference. Now we need to specify what's public, so I'm going to create the methods as public, and this is usually what you'll see. You'll see the methods being put as public and the attributes being put as private. So now we can access this method talk, but we can't access these attributes. So how are we going to actually set these and access them? We're going to use what are known as setters and getters. So we're going to create setters and getters, and these do what you might think they do. They set the attributes and they get the attributes. So these are just methods. So we'll say void set, let's do the eye color first. So we'll pass in a string because that's the type of variable eye color is, and we'll just say s. Now we need to define this function just like every other function. We declared it here. Now we can go ahead and define it outside of the class. So how to do this? We just say the return type, it's void, you can see that. And we'll go ahead and say the name of the class is human, and then we use this operator called the scope resolution operator. It's just 2 colons, and basically this just accesses everything inside of the class. And then we'll say set eye color like that, pass in our string, and then we'll define this. So we'll just say, you can see here, the set eye color function or method is inside of this class, so it can access everything in the private section. So now we're going to set the eye color that's in the private section equal to whatever the string s is. So that's all that's doing. And then if we want to create a getter, we need to first off define it up here or declare it. So we'll say it's going to return a string, and then it's going to be called get eye color, and then no parameters. And then we'll go ahead and just copy this. First off, we'll just do this. So that, and then change this to string, and we'll just change this to get eye color, like so. Now there's no parameters, and we're just going to return whatever the eye color is. So return eye color, just like that. Now what we can do is, instead of setting this directly, we can call the set function, so the set eye color right there, and pass in brown as our string, just like that. End it and get rid of this stuff. just like that. So that does the same thing. And really the whole point of having private stuff and public stuff is to make this as abstract as possible. Basically it makes it so that these attributes are secure and they're not being changed on accident or in a way that they're not meant to be changed. And it just makes it easier for any other programmer if like you deploy this as a library and other programmers are using this class. They just need to be able to set the eye color and get the eye color. They don't need to basically assume how to use these attributes. So like I said, the whole point of having private stuff and public stuff is to make things abstract. And one way you can think about this is, back to the beginning of the series, I said that most people think of a computer as just this box that sits on their desk and they press this one button and it does the things that they need it to do. But as programmers and computer scientists, we know that it's more than that. We know that there are literally trillions of wires in the computer doing complex stuff. So we know how to use those wires to do cool things. That's why we're programmers and computer scientists. But the average person just thinks of it as a button that they push and it does stuff. So that's really what the point of having private stuff is. It makes it so that we're hiding the stuff that other programmers don't really need to know about. They just need to know about these setters and getters, and anyway, let's go ahead and move on. So anyway, we can go ahead and set all of these setters and getters for each one of these attributes, but I'm not going to do that. That's just going to take too much time. But anyway, we can create multiple objects of this class. So I could do like a human Tom. I could do a human Kathy, something like that. Anyway, you can create multiple objects of the same class. That's kind of the point of object-oriented programming.